Have you ever noticed that the same machine learning technique can be used to detect cancer, recognize faces, identify spam emails, detect cyber attacks, and even monitor IoT devices? Sounds interesting, right? There is a where support vector machine, commonly known as SVM, becomes extremely useful. Hello everyone, it's me Dr. Kapil Joshi, and today I'll discuss about the application of SVM in research topics. So when we learn SVM in machine learning, we often focus on concepts such as hyperplanes, support vectors, margins, kernels, and classification. But the real power of SVM becomes visible when we apply it to real-world research problems. In today's video, we are going to explore 5 important research areas where SVM can be applied effectively. And these areas are healthcare and bioinformatics, computer vision with natural language processing, cybersecurity, and IoT with edge computing. So let's understand each application one by one. First, we are talking about the healthcare and bioinformatics. Let's begin with one most important area it is. So healthcare generates huge amount of data, including medical records, laboratory reports, medical images, and genomic information. So SVM can be used to analyze this data and support intelligent decision making. One major application is disease diagnosis and prediction. For example, suppose we have patient data containing features such as age, blood glucose level, blood pressure, BMI, and other medical parameters. An SVM model can learn patterns from previously diagnosed patients and then classify a new patient into categories such as high risk or low risk with some kind of disease, and it can be healthy. So SVM can also be applied to problems such as cancer detection and diabetic predictions. Another important application is genomic data classification. So researchers can use SVM to classify genetic patterns and identify relationships between genomic features and particular disease. So SVM is also useful in brain-computer interfaces or BCI when brain signals can be classified to control external devices. Therefore, SVM provides researchers with a powerful approaches for solving various healthcare classification problems. Number 2, computer vision. Now let's move to the next major area, that is computer vision. It means it enables computers to understand and analyze images and visual information. So SVM has been widely used for different image classification and recognition problems. For example, consider handwritten or digital recognition. So an image of an handwritten numbers can be converted into numerical features. So SVM can then learn the differences between various digits and classify a new handwritten image. SVM can also be used for face recognition, where extracted facial features are provided to the classifier to identify different classes or individuals. Another important research application is object detection in medical imaging. For example, researchers can use image processing technique to extract features from X-ray, MRI, or CT images and then use SVM to classify normal and abnormal regions. So this combination of image processing and SVM can be useful in developing computer-aided medical diagnosis system. Number three, that is the natural language processing. So it deals with the processing and analysis of human language. So one common application of SVM in NLP is text recognition. For example, an email can be classified, and something we are talking about the classification of all emails as either spam or hams. So where ham means legitimate messages. The SVM model learns from previously labeled messages and identifies patterns that categorize all spam emails from the legitimate content. So SVM can also be used for sentiment analysis. Suppose we have thousands of customer reviews. The SVM model can learn from these reviews and classify new review as positive, negative, or neutral. So this can be extremely useful for businesses that want to understand customer opinions. SVM can also be applied to speech recognition and other language or other classification tasks, making it a valuable machine learning technique in NLP research. So number fourth is cybersecurity. Now let's look at the another important growing features with some research areas like cybersecurity, cyber laws, and cyber crimes. Like every day, computer network generate enormous amount of traffic, and identifying malicious activity is becoming increasingly difficult. So this is where machine learning, include SVM, can help to develop intrusion detection system. So an intrusion detection system analyze network traffic and attempt to identify suspicious behavior. For example, the SVM can learn what normal network activity looks like. When it encounters significantly different patterns, it can classify that actively as potentially malicious. Another application is malware classification. So SVM can analyze different characteristics of software or files and classify them into categories such as begin or some kind of potential malicious are there. So therefore, SVM can contribute to intelligent security system that help researchers detect and classify cyber threats. So last one is IoT and edge computing. Finally, we will discuss about this technology that is Internet of Things. It connects sensor, machines, vehicles, smart devices, and many other systems. So these devices continuously generate data, and analyzing this data in real time is a major challenge. So SVM can be used for real-time anomaly detection. For example, imagine an industrial machine equipped with multiple sensors. The sensors continuously measures parameters such as temperature, vibration, pressure, and energy consumption. An SVM model can learn the normal operating patterns of the machine. If the sensor data starts showing an unusual patterns, the system can identify it as an anomaly. So this can help in predictive maintenance and reduce unexpected equipment failures. So SVM can also be useful in resource constrained edge devices where computational resources, memory, and energy may be limited. So by performing analysis closer to the source of data, edge-based SVM system can support faster decision making and reduce the need to send all data to a central cloud server. So what have we learned from this today's discussion? SVM is much more than a theoretical machine learning algorithm. It can be applied to a wide range of research problems. In healthcare and bioinformatics, SVM can support disease prediction, genomic classification, and brain-computer interfaces. In computer vision, it can be used for image classification, face recognition, and medical image analysis. In natural language processing, it can perform text categorization, spam detection, and sentiment analysis. In cybersecurity, it can support intrusion detection and malware classification. At last is in IoT and edge computing, it can be used for real-time anomaly detection and intelligent processing on resource-constrained devices. The most important point for researchers is that the SVM can be adapted to different datasets and real-world problems. So, if you are planning an SVM-based research project, start by identifying a meaningful problem, collect a suitable dataset, and some kind of data selection appropriate features, train your SVM model, and finally evaluate it using metrics such as accuracy, precision, recall, F1 score, and ROC AUC curve. And remember, the real value of machine learning algorithm is not only in understanding how it works, but also in knowing where and why to apply it. If you found this video useful, please like the video, subscribe to my channel, and share it with your friends, students, and fellow researchers. Thank you for watching and keep learning, keep researching, and keep innovating. Thank you so much.